Chapter 151. Lots of things are mysteries, but that doesn't mean there isn't an answer to them. It's just that science haven't found the answer yet. For example, some people believe in ghosts. They believe the ghosts of people who have come back from the dead. And Uncle Terry said that he saw a ghost in a shoe shop in a shopping center in Northampton because he was going down into the basement when he saw someone dressed in gray walk across the bottom of the stairs. But when he got to the bottom of the stairs, the basement was empty and there were no doors. When he told the lady on the till upstairs, they said it was called Tuck, and he was a ghost of a Franciscan friar who used to live in the monastery, which was on the same site hundreds of years ago, which is why the shopping center was called Greyfriars Shopping Center, and they were used to him and not frightened at all. Eventually, scientists will discover something that explains ghosts, just like they discovered electricity, which explained lightning. And it might be something about people's brains, or something about the Earth's magnetic field, or it might be some new force altogether. And when ghosts won't be mysteries, they will be like electricity and rainbows and nonstick frying pans. But sometimes a mystery isn't a mystery. And this is an example of a mystery which isn't a mystery. We have a pond at the school with frogs in it, which are there so we can learn how to treat animals with kindness and respect. Because some of the children at school are horrible to animals and think it's funny to crush worms or throw stones at cats. And for some years there are a lot of frogs in the pond, and some years there are very few. If you do a graph about how many frogs there were in the pond, it would look like this. But this graph is what's called hypothetical, which means that the numbers aren't real numbers, it's just an illustration. If you looked at the graph, you might think there was really a cold winter in 1987 and 1988 and 1989 and 1997, or that there was a heron which came and ate lots of the frogs. Sometimes there is a heron who comes and tries to eat the frogs, but there is chicken wire over the pond to stop it. But sometimes it has nothing to do with cold winters or cats or herons. Sometimes it's just maths. Here's a formula for the population of animals. N new equals lambda n old times 1 minus n old. And in this formula, n stands for the population density. When n equals 1, the population is the biggest it can get. When n equals 0, the population is extinct. N new is the population in 1 year, and n old is the population the year before. And lambda is what's called the constant. When lambda is less than 1, the population gets smaller and smaller and goes extinct. And when lambda is between 1 and 3, the population gets bigger, and then it stays stable like this. And these graphs are hypothetical too. When lambda is between 3 and 3.57, the population goes in cycles like this. But when lambda is greater than 3.57, the population becomes chaotic, like in the first graph. This was discovered by Robert May and George Oster and Jim York. And it means that sometimes things are so complicated that it's impossible to predict what they're going to do next, but they're only obeying really simple rules. And it means that sometimes a whole population of frogs or worms or people can die for no reason whatsoever just because this is the way the numbers work.